Okay, so think about this. You order something online, just one click. But that one click actually kicks off 4 or 5 different services behind the scene. One handles the order, one handles payment, one checks stock, one sends you a notification, and here's the cool part. None of them are waiting around for each other. Today I'm gonna build this whole thing from scratch in Python. We just need two things, a hash map and a queue. That's it. Let's get into it. So there's basically two ideas doing all the heavy lifting here. First one, hash map. In Python, that's just a dictionary. We are using it to store the order status. And the whole point is it's super fast to look something up. Doesn't matter if there's 10 orders or 10 million. It doesn't slow down. Second one, queue. This is the fun part. Instead of order services directly calling the payment service and waiting for a reply, it just drops the order in a queue and moves on. Payments pick it up whenever it's free. Nobody's sitting around waiting. That's basically the whole secret behind microservices. Alright, now let's actually build it. Let's just import what we need. UID to generate order IDs. Threading because we'll need a lock in a second. Time so we can fake some delay, like a real service would have. Queue for our pipeline. And random, we'll use that later. Now here's the important line. Order store just an empty dict. This is our hash map. This is where every order status is gonna live. And store lock, we are adding this now because in a bit, multiple services are gonna be touching the same dict at the same time. So we need to make sure they don't step on each other. Alright, so this function is our order service. First we make a short random ID for the order. Then we grab the lock using the with block. It automatically lets go of the lock when we are done, even if something goes wrong in between, so we don't have to worry about it. Inside we save the order into a dict, item, quantity, and status, which starts as created. Keep an eye on status field by the way. Every service coming up is gonna change it. It's basically how we track whether the order is at any point. Okay, so we make 3 queues, one for each step. Think of this like a stand-in for something like Kafka in a real company. Now this payment service function is just run forever in a loop. That gets called basically just wait patiently until something shows up. It's not wasting any CPU checking again and again. Once an order comes up, we sleep for half a second, just to pretend like it's actually processing a payment. Then we update our hash map, print it out, and push it onto the next queue. Inventory, and that's it. Payments done, is job, and moved on. Just adding one line up here. After we save the order, we drop it straight onto the payment queue. That's literally the whole handoff. Same idea again, just 2 more times. Inventory wait for something to show up, mark it as reserved, and hands it off. Notification waits, mark the order as completed, so now we have got 4 services running. And none of them are directly calling each other. Everything just flows through the dict and the queues. Now let's actually start all these services as thread. In real company, each of this would be in its own container running somewhere. But same idea. Let's create 2 orders and give it a few seconds to finish. And look at that. 2 orders going through all 4 services, nobody's blocking anybody, and our hash map showing up exactly where each order ended up. One more thing before we finish up. This whole run assumed everything just worked perfectly. But in real system, payment gateway timeout all the time. So here's a super simple way to handle that. We just wrap the whole work in a try except. If it fails, we throw it right back on the queue and try again. That's pretty basic retry. Real system usually adds some delay and eventually give up after a few retries. But the idea stays the same. A failure should have crashed the whole pipeline. It should get retried. So let's connect this to what actually happened in the real world. Our dictionary basically becomes something like Redis or row in database. Our queue becomes something like Kafka or RabbitMQ. Our thread becomes an actual container running somewhere in the cloud. Even our log becomes some kind of distributed log at a distributed level. So the whole shape of the thing doesn't really change. It's just the tool that gets bigger. So next time someone asks you in an interview, hey, how would you decouple payment from the order flow? You already know what exactly you have to say. A full working microservices set up in like 70 lines of Python. HashMap for keeping track of stuff. Queue for keeping everything decoupled. I'll drop the full code below. Let me know if you want me to redo this with actual Kafka and Redis. See you in the next one. Peace.